All right, so the first thing, Jay, that we want to do is just remember what we're looking at. So it says use your calculator to find the following information for this graph. And we're going from negative pi to pi, and this is our function. You guys did have a problem that you had to do by hand, which can become very cumbersome because then you also have to think about where you are on the unit circle. Now we get to give answers in decimal form. Okay, so we went around to 3 decimal places. So the first thing we want to do is go into y equals, and I'm hoping that you still have your derivative stuff here on the bottom. If you don't, you need to remember how to do it. Okay, so I'm going to put this function in. We've got the sine of x, okay, and minus the cosine of x. Okay? And if you forget, I will go through one time how to put this in the calculator. Because what do we need the derivative for? The first derivative, what do we need it for? Okay, slope, what else? How do I, increasing, decreasing, f prime is where the graph is above and below the x-axis, okay? So, also too, I need to set my window. So the reason why I'm showing you how to do this, I know you could look at the standard graph, but what if the question just gives you the derivative? Okay, you can't do the integral. Okay, you cannot do that. You have to use the graph that you're given. So that's why I'm showing you how to do this. Okay, so we're going to go from negative pi to pi. And you don't want your scale to be 1. It needs to be in terms of radians. So let's make it like pi over 4. Okay, and I'm thinking back to when we had to graph in pre-calc. Remember, you had to set up your graph, okay, and if it's a little bit foggy, you might want to check that out. And then let's shrink our window down just a little bit. Let's make this negative 5 to 5. Worst case scenario, if I have to go back and fix the y-axis, that's fine, but I have that all in radians. So, before I graph anything, we're not graphing yet, okay, I need to know where f is increasing and decreasing. Okay, increasing and decreasing. So what do we use for this? So we're going to use f prime. Okay? Relative minimum points and relative maximum points, we're actually going to use the original function. Okay? Because we want the points. There's lots of different ways that you could find this, but if you wanted relative minimum and maximum, you could determine what it is and then go in and plug in the value. They can't ask you for the points if they don't give you f of x. They could ask you for the x coordinates. So then you would have to do your increasing, decreasing number line and see which one's a relative min and max. Everybody okay? Okay, so go back into y equals. Okay, and what we're going to do is we're going to turn this off. So you need to be sitting over the equal sign and press enter. Okay, and then go down. How many of you do not have the derivative in your calculator? Okay, this is the last time I'm going to show you. You guys ready? I'm going to delete mine. Okay? Okay, so here you go. You want to go into alpha window. I had to remember where it was. Alpha window, and we want option 3. Alpha window. Okay, you guys really need to know your calculator. We want the derivative with respect to which variable? Yep, with respect to x. And where is our function? Where do we typically put it? In y sub 1. So you're going to go into alpha trace. There's all my y's. So I'm grabbing y sub 1. And what do I want x to equal? X. Okay, so what that'll give me is any x value. Any x value. Okay, so it's just general. So now this is highlighted. We have our window set. This is going to take longer to graph, but we're going to hit graph. Okay, remember, this is the derivative. So if we're looking for the intervals of increasing and decreasing, what are we looking for?
Above or below.
That's right. Perfect. We are looking for the location of the graph. You're on fire.
Thank you.
You're welcome. Okay, my interval is from negative pi to pi. Okay, so when I look, I'm reading the graph from left to right. So from here to here, what can you tell me about f of x? From here to here. Decreasing. F of x is decreasing. And then from here to here, also decreasing. Agree? Okay, so what I need to find are these points. this point and this point. I need the x value, because from this x value to this x value, what's happening to f of x? Yeah, increasing, because f prime is above. So what is this value right here? Well, that's right, it's negative pi. So we know decreasing, we're going from negative pi to somewhere, and then from another somewhere to pi. Isn't that what you guys we confirmed, correct? So if I figure out what these values are, then I have everything I need. Okay, I'm going to also give you guys another hint. Do you remember in Algebra 2 you had to find the zeros? So you go in and find the zero and you give it a left bound, a right bound, and a guess. There's an easier way to do it. If you go back into y equals, and in y sub 2, just put 0. Where does y equal 0? Yeah, so am I going to even see the graph? No, I don't see it, but guess what? Now I can calculate the point of intersection, and it's faster. I don't have to give a left bound and a right bound, because you know sometimes you do it the opposite way and it's wrong, then you have to start all over. So this is what you do. We want this point right here, true? This x value?
True that.
So we're gonna go into second trace, and we want to intersect. Find the point of intersection. So we want option 5. So it says, is this the first curve? I'm actually on the x-axis where Jay said that's where y equals 0. So I'm just going to press enter. Then it says, is this the second curve? It jumped to my curve. Is that the second curve? Press enter. Is it close to the point that I want to calculate? I wanted to do this left, this one right here. So it's close. It's already there, right? So I don't even have to do anything. I'm just pressing enter one more time. It calculates everything for me. What is that x value? Negative 0.7853. Okay, stop. Okay. So from negative pi to point, this had 3 decimal places, so 785. Negative 0.785. Okay, but also, what is that point significant for? Look at, don't I have to answer another question here?
Oh, it's where it starts to increase.
Yes, it's where it starts to increase, so I can use that point again. Negative 0.785. It's like a twofer, right? A BOGO, whatever you want to call it. Okay, now what do I need? Help.
The second.
I need I need this one. So we're going to go back into second trace, option 5. Okay, is this the first curve? I'm going to use my right arrow key. I want to get close to that point. Okay? So now I'm just going to, I'm sitting on that first curve, right? Just press enter. It jumps to the other curve. Is that where I want to be? Enter. And then the last, am I close to that point? I could get closer if I wanted. Enter. Okay, is this a BOGO? I get 2 for 1?
Yeah.
Yes. 2.356. Where does it go?
To the second, to the x value of the second decrease curve.
Yep. 2 point, what did I say? 356? 356. And what else? Yeah. Yes, right here. 2 point. Done. Yeah. Are we good? Yes, no? Yes, sir.
Since you set the scale to pi over 4, couldn't you just do that as the number?
What do you mean?
Because you set the scale to pi over 4, so each individual
Yes.
is on the x-axis.
Yes.
Okay.
Yes. And in this case, because I just set it to pi over 4, you could have set it to pi over 2. It doesn't really matter. I just needed an interval of something other than 1. It does depend on what you've set it to. You won't always get those nice unit circle values, but yes. And some people wouldn't even recognize it, so they would all be in decimal form. But not always. Okay, let's do concavity. Okay, and then we'll go back to relative min and max. So how do I deal with concavity? What do I use? Second derivative. This whole piece right here is f double prime, right? So I'm going to go back into y equals. Okay, I need to go down here. So for those of you that got your calculator jacked somehow, you need to do the same thing here. But this y location needs to be the one where you put your first derivative. Okay? And I'm going to highlight that. Now, here's the only problem. Second derivative is going to take a little bit longer to graph. It's super slow. So if you're fixing, I'm going to let this crawl. All right, so this is the graph of the second derivative. And since we're looking at concavity, again, you are looking at where f double prime is above versus below. So when f double prime is below the x-axis, what does it tell me about concavity? Below the x-axis.
But this is f double prime.
So that means f double prime. If f double prime is below the x-axis, is f double prime positive or negative? If f double prime is below the x-axis, that means f double prime, if you tested it on a number line, would be negative over that interval. So here, from negative pi to whatever this value is, concave down. From whatever this value is to positive pi, concave down. Agree or disagree? Okay, and then from here to here, concave up. Okay, so when we calculate these values, I still have that y equals 0 in there. I've got, this is my first curve. This is my second curve. And now I'm going to make my guess, which is right there. But it takes a while to calculate, especially the second derivative. So there you go. So when we're talking about concave down, we're going from negative pi to, what is that, negative 2.356? And then also concave up, right? Negative 2.356. So then, in order to figure out the rest of concave up and the other portion of concave down, you've got to find that other value. So I'm going to move closer on the other side. Okay, so using the calculator, not any different, right? It's doing more of the calculations for you, but you have to understand what you're using. And then I'm going to show you max and min in just a second, and then you're done. But I will show you number 53. Okay, so 0.785. So as Ben pointed out, these are actually values on the unit circle. They're just as decimals versus in radians. Well, that's a lie. They are decimals in radians, not in like pi over 4, pi over whatever. Okay, but not everybody's going to realize, and that's okay, because typically for a problem like this, we would ask you for the decimal answer. But if you gave us radian form, it's fine too. Does everybody understand what I'm saying? Okay. So this value is 0.785. So this is 0.785, and then this would be 0.785 to pi. Okay. Oh, points of inflection, and this more so would be x coordinates. Okay, because you can't give me. Actually, you could give me. Okay. First of all, what are the points of inflection? The x coordinates.
Slope changes.
Yeah, but what are they physically? X equals what? Negative 2.356, and then what's the other one? 0.785. Since we have f of x, how would I get the y values?
Plug it into the original equation.
Yeah. Okay, now, that would be a little bit challenging, agree or disagree. But you've got this thing called the calculator. Couldn't it do it for you? Okay, so you want to go into y equals. I'm showing you all kinds of stuff. I'm going to go down here. Turn this off. Go back up to the top and turn this on. This is my original function. Remember, you can change the table setup to ask. And all you have to do is go into the table and plug in the values. So let me delete this right here. So, negative 2.356. What's that? What is negative 3e to the negative 4? Yeah, it's a tiny number. So what would you put there? I heard it. Yeah, 0. Because this is negative 0.0003. It's tiny. So then what happens when I plug in 0.785? Oh, same thing.
Even smaller.
So these y values are both what? 0. Okay. Relative max, relative min. This will be easy. I'm not going to do the whole calculation, but since we have y equals, okay, if I hit graph, because I already have the window set up, this is f of x. If I'm looking at this window, do I have a relative max and a relative min?
Yeah.
Yes. Relative min, relative max. If you go into the calculator, second trace, I think, min and max. Calculate them, and all you have to do is it gives you the point. So this is the one, you have to give it a left bound and a right bound, right? This is the one it's a little bit annoying. So if I do 3, I said I'm not going to do it, and what do? I do it. Okay, so here it says left bound, meaning give me a point on the left, enter. Give me a point on the right. It's calculator speak. Give me a guess. So make your point in between those two arrows. Boom. There is your absolute minimum. Absolute max, all you have to do is the max part. Okay, does everyone understand how to do this?
Yeah.
User error? I have to look at it.